All right, fellow coders, welcome to this next lesson in our series where we are building a Spring Boot / React web app from scratch. In this one, we are going to continue our journey using Spring Security to enable the use of Json Web Tokens. JWT is a solution that allows you to have a stateless security layer, a stateless authentication and authorization layer, which works very nicely with things like React and other SPA, single page application frameworks and whatnot. So that's what we will be doing in today's video. All right, so let's dive into sort of the first, or the next step, I should say, which is to introduce this sort of filter, if you will. So this filter is going to be used to, as a part of the security process. You know, Spring Security has sort of a bunch of, they call them filters. They're like layers of security, and you have to go through each of the layers, and you have to pass each one of the filters in order to gain authorization and authentication into an application. So we're going to introduce sort of a custom filter in there to add the functionality of looking for a JWT and validating JWT data being sent as part of a request in our application. So we need to create a filter. So why don't I create this new class? We'll call it the JWT filter, and we'll add it to I'm not sure what package you would add it to, like a filter package. This might be the only class in the filter package. I don't know if I would call it a utility because it is a filter. Anyway, whatever. If there's only one thing in this package, then so be it. So we need to, I believe, mark this as a component so that it is managed by Spring, and so that therefore we can leverage it and inject it into our security config later. So our security config here will have reference to our JWT filter, our JSON Web Token filter. So within here, we also need the ability to grab a user from our database. So actually, I'm going to very quickly change angles here and add a repository that allows us to do the CRUD operations with the user. In other words, creating, reading, updating, and deleting a user. It's quite simple because we're leveraging Spring Data JPA. Let's create a new interface this time. The CRUD functionality that you get from Spring Data prefers that you use interfaces, and we'll put that into a repository package, and we'll call this the user repository. Okay, so just an interface, plain old interface, nothing crazy, which extends something called JPA repository, okay, which comes from Spring Data JPA. So extending this allows us, it gives us the functionality to use all the CRUD functionality. So if you look at JPA repository, if I F3 into it, when I F3 into it, it has find all, find by ID, save, blah, blah, blah. There's a bunch of different functions, sure, that you get access to. Deleting, in other words, CRUD. You get the creating, reading, updating, and deleting, a lot of basic and useful queries and whatnot built in without having to write any code except for this, okay? But it has some generics. So one Java generic it requires is the type of the object that you are going to be interacting with the CRUD, right? So what table are we interacting with? Well, we're interacting with the user table, which comes from our user from the domain package. So I'm going to import that guy. And then what is the data type of the ID for this user table? What is the data type of the ID? So if we look at user, F3 into it, the data type of the ID is long. It's a long data type. So we put in long. And that's it. That gives us the standard, boilerplate built-in queries for CRUD, creating, reading, updating, and deleting data for a user. Done. Really cool. Love it. Spring Data JPA is a godsend. It's so cool. Anyway, so having said that, now that we have this repository that we just added, we can now do some CRUD operations. So how about we make our code a little bit better? I think it was user detail service. We hard coded a user in here. Remember, we had done that in the previous video. Now, because we have a user repository, we don't have to hard code anymore. We can actually read from the database. So let's auto wire in our user repository that we just created. I'll call it user repo because I'm lazy. And let's import user repository from our repository package. And now, instead of hard coding a user, which is bad form, we can leverage the user repo and say find by username. Okay, we'll pass in the username, and this will return hopefully a user. Now, find by username doesn't exist, Trevor. What you're trying to create a method, or you're trying to leverage a method that doesn't exist inside of there. Well, we're going to create it. We're going to create it in there, and we're basing it off of the user has a property called username, I think. Let me double check. Yes. So the user has a username, and let's go back to here. This, for the repository, because this is a Spring Data JPA repository, when we say find by as a prefix for a method name, this is a special name, a special prefix. Spring Data will see that I'm trying to leverage or trying to utilize a method with a prefix of find by, and then it will automatically figure out the next essentially noun or combination of nouns or whatever to try to match that to a property in the object that backs the repository. In other words, what table is this repository querying, and does this property exist in that table? Does this column exist in that table? So in other words, I don't have to write any code. Or rather SQL. I don't have to write a query. I can just create this method inside of our user repository. So boom, user repository. I'm adding find by username. Now it's not going to return void. It's going to return, I believe, it returns optional user. So it should return one user, or it could not return any users. So it could return optionally. It could return nothing or one user. Okay. So Spring Data JPA is going to see this method, and it's going to write the query for us. It's going to do select star from users where username equals, and then the username property that we're passing in here, or the username parameter, I should say, that we're passing in here. How cool is that? I didn't have to write the query. I just write a little method stub, and Spring Data does all the rest of the heavy lifting. Absolutely love it. So there we go. Now we have a method to find the user by the username. So instead of hard coding the user, we can do this. Control-2L. I always do things quickly, and people ask how I did it. If you go put your cursor at the beginning of a method that returns data, this method returns optional of user. If you have a method that returns any data, you can go in front of it here, hit Control-2, which brings up a little menu in the bottom right, which my face, if I maybe lean out of the way, you can see it. Yeah, there you go. This is high-tech solution, ladies and gentlemen. My chair might be in the way. Hold on, let me move my chair. There you go. So there's a little menu in the bottom right, and you see Control-2, and then L, if I move the cursor down, you can assign it to a local variable. So if I hit Enter, it assigns it to a local variable. So Control-2L is the shortcut key to do that. Control-2 first, you let go, and then L, boom, then it assigns it to, it essentially creates the type for you and then picks a variable name that it thinks is decent. We're just going to say user, So anyway, actually we should call it user OPT, I think is the proper convention for when you're returning or when you're dealing with an optional wrapper. So it's user OPT, meaning an optional user. So now we don't need any of this, right? We don't need to hard code a user. We can say return user OPT dot or else throw an exception. So the exception that we throw here, this is a supplier. I can't remember off the top of my head. I've done a lesson on supplier. Supplier new username not found exception. I think supplier doesn't. Yeah, I think so. Right? Does that work? And then, does this need a message in here? String, yeah. Invalid credentials. Is that happy? Sweet. Okay, so it's the supplier type. So this takes supplier. Again, I've done a podcast episode on this before. Supplier takes no arguments and returns something. It returns, well, something. It returns something of type X that is defined by whatever you return. So this will essentially throw a username not found exception, which I think is true. I'm just going to check my reference article really quick, which, by the way, from TopTal, this is what I'm referencing. This is what I'm sort of walking through. TopTal, great organization. Again, I should reach out to them for sponsorship because they're a great organization. They hire the top talent in terms of developers, like a top, 3% of developers, and give them jobs. I've interviewed with them before. So, or else throw, and then, yeah, so it has a supplier, new, blah. Cool. So, by the way, this is not a good error message. They say to say user whatever is not found. I don't know if that's a great username because a great message because you're giving away some of your hand. You're showing your hand by saying, hey, this user doesn't exist. And if you return that message, if you say this user doesn't exist and then return a different message, if the user exists but it's the wrong password, then a hacker can gain access to at least the knowledge of knowing what users exist in the system. So they can put in a username, and if it's not found, it'll say, yeah, hey, user not found. So they know that that user doesn't exist. Then they can try a different user, and if it says invalid password, bingo, now I know that this user exists in this database. One piece of the puzzle has now been solved and figured out, which is not good. You never want to allow hackers to get access to that kind of info. So anyway, as you can see, we have simplified our load by username quite substantially. So that's wonderful. So now this is a legitimate load by username. It's actually querying our database using our repository. Great. We also no longer need this custom password encoder. So I kind of want to refactor this code a little bit. Is this the right time to do it? We'll refactor that later. I'm going to take out my custom, my custom password encoder, because that was not good code in my opinion, which we talked about in the past episode. Anyway, we'll come back to that. So let's focus. We've got our load by username fixed up. It's refactored. We've got our user repository. Great. So now coming back to the JWT filter conversation, we need to be able to get access to that user repository, user repo. Okay. Because, well, we need access to it for this JWT filter to work properly. All right. So let's go ahead and Control-Shift-O to AutoWire in, import the AutoWired annotation. And inside of the JWT filter, one thing that we're going to need to leverage is some methods that are going to help us to parse and validate the actual JSON Web Token itself. So the JSON Web Token is essentially a string that contains all of the information to validate that a user is who they say they are, as well as, some more any other information that could be useful as it pertains to a user. So essentially, how do you validate that someone is who they say they is? Well, at some point they will have needed to given you their username and password that together are valid. So when they give you a username and password that are valid, and we can verify that they are valid, we can then give them a token, which is just a fancy word for a string, that represents, that is signed. So it goes through a process to be signed. We, have a secret password that we have on our end that is not exposed to anyone else. It's a secret to us. We use that secret in combination with some other stuff to digitally sign, so to speak, this token. There's an expiry date for this token, so it only lasts for a certain period of time. So there's like a timeout, there's a session timeout built into this token. And then it has some basic information about the user that we'll need to know going forward in the application. So in other words, when a user logs in, we need to know when a user sends a request, which user is requesting this information or this, access to the application. I want to log in and view my profile page. Well, who are you first? Well, here's my token. Oh, I see, you're Trevor Page. I see the token, it's a valid token, it hasn't expired yet, it's been signed, so I know that you are who you say you are, and so on and so forth. That's what a JSON Web Token is. It's just a long string that's encoded. It looks like a bunch of garbage, but there's meaning behind it. And that's the benefit of using JSON Web Tokens is you can pass this in with every single request, which makes it stateless. Okay, the server doesn't have to store anything and manage anything. The client does this for us, so that's nice. Now, having said that, we need some sort of utility to be able to perform all these actions, to create it, to sign it, it being the JSON Web Token, to validate it, and all that good stuff. So in order to do that, we sort of need to code this in. So one thing we need is a tool that we can import as a dependency. Excuse me. So we go to our dependencies list. We can add a new dependency. Let me see. Group ID. I should have really just copy pasted this. I believe the group ID is io.json web token. And the artifact ID, does it autocomplete anything for me? No, it's not smart enough to do that, eh? Let me look this up. JSON Web Token. I'm just going to go type in this search. So I'm going to go to Google, type in IO JSON Web Token Maven, because I use Maven. And here it is, JWT. That was the artifact name. So the most recent one and the most frequently used one is version 0.9.1. I'm going to click on it, and there's the dependency that I could just copy paste. So I really should have just done that the first time, but let me copy paste over the dependency that I started to code in manually. Control-Shift-F to format my code, and there we go. Let me just separate the dependencies out. So that will bring in the JWT code version 0.9.1, which allows us to leverage some of the things that we'll need for leveraging or for using our JWT util or token util, whatever you want to call it. So we need to create this utility. So let's go to our util package and create a new class. We'll call this our JWT util. Okay, and this is where we're going to be able to do a bunch of stuff like validating the token and so on and so forth. So without going into a crazy amount of detail and to save time, I'm going to copy paste some code. Now you can find this code pretty much anywhere on the internet. You search for JWT util or whatever, and you'll find it. I'll also include it as a part of somewhere in the link below. I will have a link to my repository, so I'm going to paste it in. I hate when people do this. I know they paste in some code. Let me just get rid of. Let me format this a bit. Implements serializable component. I will move this up here. And imports I will move up as well, and then get rid of this class, delete, and then Control-Shift-F to format the code. So as you can see, there's some stuff here going on. So there's a version ID. This doesn't matter. You can generate whatever version you like. The token validity, as you can see, this is like probably seconds, minutes, hours. So this is like it's valid for 5 hours. I don't personally love to have tokens that, if you're just using the tokens for logging in, I kind of hate it when systems log me out automatically after like a day or two. I kind of want to give a lot of time. Anyway, there's lots of, professional security people will probably jump down my throat by saying this, but from a user experience perspective, it's annoying to have to log in every single day. So I'd rather give this way more than 5 hours. I would say times 24 hours times, let's say 30 days, right? So days, hours, minutes, seconds, 60 seconds in a minute, 60 minutes. Oh, this is probably hour. 24 hours in a day. Times 30 days. Yeah, I think that's right. I think that could be like 30 days, or that could be like some random crazy long number. Anyway, now, as you can see here, it's bringing in a secret. So our secret can be stored externally in a file so that we don't have to check it in with our code, but the @value annotation here is empty. So in other words, it's not looking anywhere specifically for the secret. If I go to my application properties in resources, we can add a secret, right? So we can call this the JWT Secret. Okay, you can call this property whatever you like. I just made up JWT.secret. It doesn't have to be that. It can be whatever you like. And then we can generate a secret code, right? So I'm going to go to, I use LastPass. I'm going to just do this off screen. I'm going to generate some crazy long string, maybe, I don't know, how about 68 characters long. I'm going to copy, paste. There you go. That's our secret. You know, it's just a random, you know, bunch of letters and symbols and numbers, uppercase, lowercase, all that stuff. Doesn't matter. It's a password, right? Essentially, that's all this is. Generate your own password, and this will be for your own signing of the code, or signing of the util. Nope. Try again. Signing of the token. There we go. So JWT.secret is the key. This is the value. So this is the key, JWT.secret. So in order to grab the value here, that's what we were using over, where was it, JWT util? Here, @value, you wrap it in, I think, this sort of Spring expression language notation, and paste in the key, and that should inject the value of the secret, the value from what we assigned, that, you know, whatever, 68 character code, password, whatever you want to call it, secret value. It'll inject it into this variable for us, if all goes well. Now, there's a whole bunch more code, and I know it's going to be a little overwhelming, but essentially, what do we have here? What can this do? Well, this can get a username from a token, and it takes in a token. In other words, the token, like I said, is going to be a bunch of garbage. It's not going to make sense. It's not going to be human readable. It's going to be encoded. But you give it that token, and it will pull out the username from that token. So you give it some garbage, and then this method here will return the actual username from that token. That's helpful, right? Same thing, you know, to get the issued at date, the expiration, and there is a thing called claims in the token. This is if you want to add your own custom claims, you know, your own custom extra data into the token. You can do this. You can get all the claims. You can check and see, is it expired? So these are all utility methods. Ignore token expiration. Here you can specify tokens for that the expiration is ignored. Okay, interesting. Generate a new token, it does this, blah, 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 blah. It uses this signing. I'm trying to see if there's any code in here that's unique to the place I copied it from. It doesn't look like it, right? This looks very generic. The only thing that was not generic was the constant value up here for when it should essentially expire, and the actual secret value. So it's very flexible, very generic code that you can leverage yourself. Okay, that's why it's widely available all over the place. This should really just be available as part of a package all on its own. It might be, but anyway, there you go. We have it in our app now. So now we can leverage a JWT util object, right? So we can auto wire in the JWT util into our filter. Okay, so we have this utility object class that does all the inner workings and ins and outs of handling the token, the claims, all the stuff that go into, it's all the utilities that you would want in order to be able to use a JWT properly. But then there's the filter, and the filter is tied to Spring Security. It's a part of the security filter chain that Spring Security goes through, and it checks each of these layers, filters, to make sure that someone is actually authenticated and good to go. Okay? So how do we build out this functionality for our filter, right? Well, for our JWT filter, we need to extend something called once per request filter. In other words, you only want this filter to happen once per request. So when a user requests some sort of information from the server, you just want to validate, you want to pass this through once to make sure that they're good. And then you don't need to do it again and again and again. And this comes from the Spring Framework web filter. Okay. From here, we essentially have to, or can override what you call it. Well, let's hover over this and add the unimplemented methods that come from this once per request filter, and that is do filter internal. So that's something that we're required to override because it is somewhere defined in here once per request. It is right. Where is it? Here? That's a final. Where is, go back to here. Do filter internal. Is that the one? Do filter here. Do filter internal. So this is an abstract method. It's protected, but it's abstract. So since it is an abstract method inside of, is this an interface? It's an abstract class. It's an abstract class, so it has some body, some methods defined already. But this one is an abstract method, so we are forced to override it to give it functionality. So this is where the magic is going to happen with our JWT filter. We need to have it do something internally with this filter, right? We need to have it do something useful, right? That's the whole point of this filter, is to do something when Spring Security hits that filter and executes the filter. So we're given this, we have a request, a response, and the filter chain. Remember, there's a chain of filters that Spring Security has that we go through. And there's a bunch of stuff that we can do. Now, again, forgive me, I'm going to copy paste because this video is going long, but I will explain all of the code that I've copy pasted. And this code is not going to work. It's going to need some customization, most likely. So I will paste in the code. This comes from the TopTal article, but again, I will do my best to explain everything here. So, first thing that they say is get the authorization header and validate. Okay, so basically when a user submits a request to our application, so this will be from the front end, from the React side of things that we haven't touched yet, they're going to have to do a request, an HTTP request, get, put, post, delete, or whatever. They're going to have to issue a request from the front end. It's going to go to the back end, to our server side, to our Java code. It's going to get intercepted by Spring Security in this filter, and then we're going to take a look at it. So basically we're saying, hey, is there a header? If there's a header with authorization in it, so in other words, if there's an authorization header, then we can check and see if, well, we'll check and validate it, right? So let's import HTTP headers, probably from Spring Framework, most likely. Good. And we're checking to say, hey, is this header empty, or does it not start with bearer? Meaning our Json Web Token is going to be prefixed with bearer first in the header. So if it doesn't have bearer in it, or if it is empty, then we just say, hey, move on, go and do whatever it is you need to do. Now it's looking for the word chain, so we're going to change the filter chain to be called just chain to make that work. And also is empty, I'm assuming this comes from like string utils or something. Is it string utils that is empty? Let's see, import it from Spring Framework. Is that the one that's deprecated? It's deprecated. What's the one that we should use instead of? Oh, come on, give me a... Let's see, what does it recommend? Is empty, blah, 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 deprecated, in favor of has length and has text. Okay. So we'll say has text. There. Cool. So that's the first thing we'll do is, hey, if this is not a JSON Web Token, forget about it. Just move on with our lives. That's sort of what's happening here. If we, therefore, if we, so we execute chain.doFilter, which just passes it on to the next one in return. It passes it on to the next filter in the chain of filters is what this code does, and then moves on with our lives. So in other words, ignore it. If we get past that, however, that means that we do have a bearer token. We have a bearer, we have an authorization bearer in our header. So we want to grab that token and we want to validate it. How do we validate it? Well, this is using JWT Token Util, but remember I called it JWT Util. And I don't think it's called validate. I think ours was called, what was it? Validate token. So just slight naming tweaks. So it's validate token. Oops. Validate token. And you pass in the token. Now, why is this failing? It says the method validate token string and user details is not applicable for string. Oh, it needs user details as well. So user details, because it's saying get username from token and then return username equals that. So it's doing a check on, okay. So we don't have the user details as our user object at this point. I'm sure somewhere down here we get the user object. Yeah, it does it right here. Get user identity and set it up. So let's just do this first, I guess. So we'll have this happen first. JWT Util, username from the token. Now the token we need to grab here first. Okay. Now get username, it's called from token. There we go. So user repository, find by username. Oops, we already have that method in here, right? We created that earlier in this video. This returns the user details type. So fair enough, we can do that. Cool. So if we have the user details, then we can pass that in here, user details, which is what this validate token wanted. Cool. This username and password authentication token wants list. Let me import JWT list. Boom. Okay, so we have everything compiling. So let me walk you through what's going on here. So do we have a bearer? Do we have an authorization bearer token? If yes, or if no, then we kick it to the next one in the security chain. We don't care. Move on with our lives. If we get to this point, then we do have it. So we want to split it out. So basically what our request will look like, the request is going to have, as part of the header, it's going to have, it's going to be an authorization is the key. And then it's got the value, key and value pair. The value is going to be bearer with a space. And then there's going to be the gobbledygook, the garbage that is part of this whole string is going to be the JSON Web Token itself. Again, this is not going to be human readable. It's going to be encoded. There's going to be dots separating all the parts. But basically what we want to do is we want to write code to take this value and split it by a space. So there's going to be one space. We're going to split it. So it's going to split it into this part, an array of two values. So that's what this does. It splits it into an array of two values, which is what this is. This will be an array of two values. And then we're going to say, get me the index at 1. So in other words, don't give me this one. I don't care about this. I want this. So I want the token. And we're going to trim it just in case there's, leading or trailing spaces, and assign that to a value called token. So in other words, we're just grabbing the token out of the header. Great. Now with this token, now we can do something, right? We've got this token. It has all the details we need inside of it. It has the username, it has the expiry date, it has all the info that we love and need. So we're going to grab the username, JWT Util get username from token. So we have the token. We're going to pass it into this method called get username from token, which is going to grab the username from the token. It's going to use that to do a user repository find by username, right? In other words, it's going to look this user up in our database. If it finds it, then it's going to assign it to user details. If it doesn't, it's going to assign null to user details. So now user details will be populated. With this, then we can validate the token. So what happens in validate token is does it do the exact, see, this does the exact same thing, I think. Oh, no, it doesn't. Never mind. We're good. I was going to say it looks it up again, but no, it does not look it up again. It grabs the username from the token and makes sure that that username matches the username in the user details object, which is the user object. And then it just checks to make sure it is not expired. Those are two things it does to validate. Does the username match, and does the is it non-expired? So that'll return true. If it does not return true, it does not validate. It does not. It just sends it to the next chain in our filter chain of authentication. So if the usernames match, well then we do this. We do a username password authentication token. We generate this and we pass in all these details. So what does it need? It needs our principal. So it's passing in a few things. The principal is user details. That's essentially our user object. And then it's passing in null, and then it's passing in, so it's using the 3 argument. So this one. So the principal is the user details. The credentials we're saying are null right now, which is interesting. I'm not sure if that's going to work. We'll see. And then authorities. Now, oh good, it's getting authorities from the user details. Perfect. So it's leveraging our existing code. We already wrote that code. Beautiful. So that's what it's doing. If the user details exist and is not null, then it will grab the list of authorities. If it is null, it's going to have no authorities, which is just not going to work. And then we're saying authentication here, which is the username, password, authentication token. We're setting the details with this. Now, I've never seen this before. This is new to me. Web authentication details source build details request. So interesting. Authentication is this username. Okay, so that's tied in with this guy. I've never used this object before. This is new to me. From Ben Alex, an implementation that is designed for simple presentation of a username and password. Okay. So we build out that authentication information, and then we set it into this. So this is, so security context holder is what, and then, so we get the security context holder and set the authentication, meaning what we do is, this is Spring Security's way to programmatically validate a user and put it into our world, in our security world. In other words, we are saying this is a valid user. I am now injecting it into our Spring context, meaning that they will not have the access that they should have access to. So they're, as per their roles, they will have access to everything that their roles define. So in other words, we're saying you have successfully logged in. Boom. That's now what you can do programmatically to say someone has successfully logged in. Okay, and then we pass it on to the next filter. So this is where the magic happens. This is where the authentication magic happens, and the user is now valid, right? So right here, that's where the magic happens. We inject the user in, and we should be good to go. Now, we're not setting any credentials, which is odd to me. To me, I feel like we should have credentials here. So I'm curious to see if that's gonna fail or not. It might not. I'm trusting these guys, so we'll see. But anyway, that's the only question mark I have is there's no, why wouldn't we say user details dot get password, right? Or is that a security problem? Anyway, that's what I would put in there. If the null value here does not work, I would probably inject the password. But anyway, we'll see what happens. So now we have this little filter, JWT filter, that we can hook into Spring. We haven't hooked it in yet. We've created the filter, but now we need to tell Spring to use this filter, Spring Security, I mean. Because right now, Spring Security is not using this filter. And if we try to boot up our app, well, first, we might get a bunch of errors. So let's try to boot up our app and see if we have any errors. But if we try to boot up our app and there's no errors and we try to log in, it's still going to have the same login flow. So there was no errors. Great. That's always a bonus. So now if we try to go to our login, so localhost 8080, we see the exact same screen as before, right? So this is not helpful. This is not what we wanted to do in terms of JSON Web Tokens and whatnot. So yeah, we need to override this functionality and leverage our new filter that we've added in. So how do we do that? This video's going long. I try my best, even with copy-pasted code. I try my best. So how do we leverage this code? I'm just sort of scanning this document. Let me hit pause so I have a good direction on where to go next. Okay, so now in order to, like I said, to tell Spring Security to use this filter that we've just created out of thin air, we need to go to our security config, right? Security config is the behemoth of, this is where all of the security configuration stuff happens. This is where Spring Security lives and eats and breathes and all that stuff. So we have our authentication manager builder where we're injecting a user detail service, which we defined already, and we're passing in the password encoder. I believe this is where we need to pass in, oh no. So this code will validate our user. So this is gonna do the authentication, right? Hence authentication. And then there's authorization, which means, okay, now that you've authenticated yourself, what access should you have in this application? And that's where this next configure method comes from. So instead of invoking the super.configure, in other words, instead of invoking the web security configurer adapters version of their authorization code, not authentication, but authorization. Instead of doing this, we'll put in our own code. So how do we do that? Well, we need to leverage the HTTP security variable here. We can say equals http.cores. We'll come back to cores. Can I say disable? We'll disable cores, and we will say, do I say and? Disable. HTTP cores, disable. Can I say HTTP CSRF disable? .cores disable. Okay. Now, is that going to work though? Do I just disable cores? We'll see if that works. Cores is cross-origin resource sharing, which is a mechanism for preventing hackers to, it's a hacker thing. So it's a security measure that we use to reduce hackers' ability to gain access to vulnerabilities in our system. In other words, you should not disable these two things. Okay, I'm just disabling them for the time being. We will come back and refactor this code, enable them, and actually leverage them properly. So do as I say, not as I do. Then what else do we do here? So we need to, this is where we inject the, we tell it to use a stateless system, a stateless authentication system. So policy, there we go, stateless policy. So we can say session management, this one. I guess I can just say session management, session creation policy. Session creation policy is you inject a session, creation policy .stateless. Okay, so we have a stateless session creation policy. And what else? What else should we do? So the code here, again, I'm just sort of looking at the code they have. The next step that they have is to set unauthorized requests, an unauthorized requests exception handler. Interesting. Let's do it, because again, I haven't done this before. This is from TopTal, and they are, like I said, a great organization, so I trust their code. So essentially, we're adding exception handling in here. Oh shoot, I have a meeting coming up. This video is going so long, I forgot about my next meeting. So I guess I have a hard stop soon. So we have exception handler, and they have the authentication entry point. So authentication entry point sets the authentication entry point to be used. If no whatever is specified, then the default will be used. Okay, so we're overriding the default functionality, and we're using an authentication entry point, which wants an authentication entry point object. Now their code is injecting a lambda expression, which I do not see the lambda expression as being an option for the code that I see here, which is interesting. So they are injecting the request, the response, and an exception, and then they are doing something with that. They're saying response send error. Look, it actually got one. So they're sending the HTTP servlet response, HTTP servlet response, which comes from, HTTP from Java X or whatever. So they have SC unauthorized. So unauthorized is like a, what is that, 403 or 401 or 402. It's one of those 40 something codes. It's sending that, and it's saying the get message from the what you call it, exception, and then close curly bracket, close this, and oh my gosh, that worked. Okay, so what's interesting is the authentication entry point. It required an object. This is what this is more of a high level Java thing. The authentication entry point looks like it needs an authentication entry point object, right? What does this look like? So if I were to create an authentication entry point, let's say auth or whatever, and if I hit F3 on it, it's an interface. It's not a functional interface, but it is an interface with one abstract method in it. So although it's not marked as an abstract, as a functional interface, it does meet the requirements of a functional interface. And these are the methods that it's, or the parameters that it's taking into its method. So it's taking a request, a response, and an authentication exception. So that's where we got this from. Request, response, and so request, response, and EX are from the single abstract method in here, from the commence method. It has these three. So, cool. Although it's not marked as a functional interface, it can be used as a functional interface and injected as a Lambda expression, which is nice. So, and then we can go on to hopefully have time for this, to add in, let's set everything to be, any request. Oh, how to do this? Authorize requests. Authorize requests. So we're saying, hey, in terms of authorizing the request that comes in, we'll say any request has to be authenticated. Is what we'll sort of do. Do we need to say and? Is that? How come that's not happy? Oh, because they're not assigning it to anything again in their code, like that. I guess that's because it's the last thing that they're doing in their code. Perhaps authenticated, and then is there anything else that they need to do? And then we need to also, this is the goal of this whole thing, was to tie in our filter. So here they say add filter before. Okay, so we can add a filter before anything happens, and that is our JWT filter, right? Which we need to auto wire in. We haven't done that yet. And before filter what? Well, it's before they say before the username password authentication filter class. So before the built-in whatever username password authentication filter happens, do our filter first, which we'll have to inject in here. So we'll auto wire in our filter, JWT filter, which is what we created ourselves earlier, right? That's our code here. If I go to it, that's our code with all this stuff that we copy pasted from their article, and then refactored to be valid for our own code. So there you go. We have now injected our filter before the username authentication filter. Now they also have one more little thing that they do in a configuration in the application properties class. They have one property here, Spring Security Filter Order 10. So they say to do this because, and I can bring this over, they say, one important detail I want to mention is that Spring Security filters are registered with the lowest order and are the first filters invoked. For some use cases, if you want to put your custom filter in front of them, you will need to add padding to their order. This can be done with the following configuration. Okay, so once we add this configuration, we will have space for 10 custom filters in front if we wish. So I feel like we already did that. We already did this inside of our configuration in here with this line of code. So I feel like this is redundant now, but in any case, I want to sort of follow their lead. So I have 4 minutes before I need to bounce and go to a meeting. Let's boot this up. Hopefully it doesn't crash on us. Okay, it didn't crash. Let me open up a tab and try to log in, or not log in, but try to access something. Beautiful. Okay, so you see what happened? HTTP error 401. So 401 means the credentials didn't work, right? So it was rejected. So if we go to our thing here, there's a null pointer exception in our JWT filter. Line 39, boom, we got, well, null pointer is not what I want to see, but basically there's a null pointer because the header did not, or the request didn't have an authorization header. right? So really, we should also say, shouldn't have been has text? Shouldn't that have caught that? I thought has text checks for null. Yeah, if string is not null. So where was the... Why would there have been a null pointer here? Because it should have rejected it right here. That's odd. Has text. Because if I put a breakpoint here, and if I reboot the code, stop, start, boot up, reload the page, it should hit my breakpoint, and then the breakpoint here, we should be able to inspect this, and it says false. Okay, so, because it's an OR. Because it's an OR, it goes over here to check. So, really, this should say, if it doesn't have text, and, if it has text, and the header doesn't start with bearer, right? Isn't that the right way to say it? If it doesn't have text, just stop, because you're going to get a null pointer. If it does have text, but it doesn't start with bearer, yeah, to me this makes more sense. So if I reboot, oh god, I gotta go. Typical developer. Just one more try. I just want to try one more thing. Refresh this page. It gets into here. Oh, and then it skipped and tries to... Well, that didn't work. Okay, so I will need to figure out how to solve the problem of if it's null, then I need to just send it through the chain. I don't want it to have a null pointer exception. That's the wrong kind of exception, in my opinion. So we will revisit this in the next video. So thanks so much for watching. Take care of yourself. Happy learning, and bye for now.